Hello everyone, my name is Dr. Shobha Sharma from ABES Engineering College, and in today's lecture we will discuss about rectifiers. So what is a rectifier circuit? It is a circuit which converts AC to DC. Basically in our houses we are obtaining AC input signal at 220 volts and at a rated frequency 50 Hz. But in many electronics applications, we need DC power supply. So in that case, we use this DC power supply to obtain a constant voltage across the load. So the AC input voltage is provided to the transformer. In this case, the function of transformer is to bring the level of AC input voltage to a desired value. For example, if in any case we want more voltage, then this transformer can bring the AC input voltage at a higher value. And in some applications, we need lesser voltage, so a step down transformer is used to bring the AC input level to a lesser value. So the transformer is used in two ways. It can be a step up transformer or can be a step down transformer. Now, the AC output of the transformer is provided to the rectifier to convert it into the DC voltage. But the output of a rectifier is a pulsating DC. That means it has some ripples, some AC component in the output. That AC output is reduced using the filters. Basically, the operation of the filter is to remove those AC ripples from the rectified output. Now, that DC output voltage is provided to the voltage regulator. This voltage regulator block is a very important block in analog electronics, and it is made up of Zener diode. It is a very important application of Zener diode, which is used as a voltage regulator. The function of this voltage regulator is to maintain a constant voltage across this load. Load can vary. That means the value of this load can vary in different applications. So to maintain a constant voltage across this load, a voltage regulator is used. So we will discuss more about rectifier in this video. A rectifier is divided into two parts. It can be a half-wave rectifier or it can be a full-wave rectifier. So uh, a half-wave rectifier, as the name is suggesting, it can rectify only the half wave. That means that incoming AC input has two halves, a positive half and a negative half. The half-wave rectifier can rectify either the positive half of that input voltage or the negative half at a time and give zero output for the other cycle. That means for a positive half rectifier, it can rectify only the positive half and will give zero output for the negative half and vice versa for the negative rectifier. In case of full wave rectifier, it produces output for both the halves and it can be constructed using these two types of rectifiers, center type rectifier and bridge type rectifier. In this video, we will understand the working of half wave rectifier only. So this is the circuit for a half wave rectifier. Here the AC input is provided to the transformer. This is the primary winding of transformer and this is the secondary winding. So whatever input we are applying here will appear across this primary winding. And due to mutual induction, a voltage is appeared across the secondary winding. That voltage is basically the input to the diode circuit. So this circuit can be explained using this simplified circuit where we are considering only the secondary windings or the secondary coils voltage. So this input voltage has both the halves, that means the positive and the negative. In case of positive half, this diode will be in forward bias condition and can be replaced with a short circuit. And in negative half, this diode will be in reverse bias and can be replaced with a open circuit. It can be understood using these two figures. Here, in this case, when the positive half of the input encounters, the diode becomes forward biased and is replaced with a short circuit. Now, in this condition, the circuit is complete and a current will flow in this loop. Due to that current, when it flows through this load, a voltage is appeared across this load. So, for a positive half cycle, output voltage is obtained across this load. When the negative half cycle comes, uh, this diode is in reverse bias and is replaced with open circuit. Now, since this circuit is incomplete, no current will flow in this loop and we will obtain zero output across this load. So, let us discuss the complete working. This is the input. Alternating input is coming to the transformer. Now, when this positive half comes, this basically this end of the diode is connected to the positive half and the negative end is connected to the negative half. In this condition, the diode comes in forward biasing and is replaced with short circuit. In case of short circuit, the circuit is complete and a current flows and a output is obtained across the load. And this output is shown here for the positive half cycle. In case of negative half cycle, the polarity changes. This terminal becomes negative and this terminal becomes positive. In this case, the anode end of the diode is connected to the negative and comes in reverse biasing. Due to reverse biasing, it is replaced with open circuit. And since the circuit is incomplete, no current flows in this loop. And hence, no output will be obtained across this load. So for a negative half cycle, no output is obtained. So this is the complete input-output waveform for a half-wave rectifier. For this positive half cycle, we are obtaining the output. But for the negative half cycle from pi to 2 pi, the diode is in reverse bias condition and is replaced with open circuit. So for this duration, we will obtain zero output. Okay, again for the positive half, we will obtain the output across this load. So basically, this is the waveform for a positive half-wave rectifier where the circuit is rectifying only the positive half, while we are obtaining no output for the negative half. If we have to construct the negative half-wave rectifier, we just have to reverse the direction of this diode, and in that case, the output will be obtained for only the negative half wave. So this was about half-wave rectifier, and for more details, you can refer these books on for half-wave rectifier and full-wave rectifiers. Thank you.